What's going on, guys? Welcome to part 5 of the Transformer tutorial series. And in this part we will be just creating some materials for the remaining objects we created in the previous tutorials. And yeah, so it sounds like a really chill tutorial, but it's gonna be actually a little bit more than that, because one material is gonna be really complicated. For some of you guys who don't have a lot of experience with node setups. So I'm gonna give you guys a little, almost something like a math class to set up this complex material. So yeah, that's what we're gonna do today. Let's just start with a simple material for now, and then I will come back to the mathematics stuff. First, we can see all this crap going on with the ground here. I don't know if you guys can see it on the screen recording, but it's looking very weird. So let's see what happens here. We have actually two exactly the same objects on top of each other, so I'm gonna just make one of them a wireframe, and the one I want to make a wireframe is the ground deflector. So set the display type to wire, and there we go. And then also make sure it's not gonna be rendered. So I'm gonna collapse or expand the group and press numpad period and disable the renderability of this ground deflector. And then I can go back and collapse this group. Alright, so let's start adding a material to this ground. Let's first create a new cycles material, and yeah, just create a new one, and I'm gonna call it asphalt ground. Alright, so we have a separate material for the ground, so let's go with control left arrow to the compositing layout, and let's add a new mix shader and mix in some glossy, because this is wet asphalt, so it has to be glossy. So, and let's set the roughness to 0.02 to make it a little bit more sharp. And this is really useful, this little material preview, to see what it's gonna look like. And then I want to set the diffuse color. I want to make it a little bit darker. And now it almost looks like a chrome ball, so that's not what we want. I want to actually make this reflection more like water. So to do that, I can add an input Fresnel node to set the index of refraction. And water has an index of refraction of 1.333. So that starts to look like something wet. So now let's go quickly back to my default view to have some more room here, and let's see what the original shot looks like. So I'm gonna increase the opacity, and of course I have to look through the camera. Alright, so this original shot has some distortion in the reflections. To recreate this on our CG ground, we can add a texture. And actually, when you look at this movie, the original shot, it's the reflections are a little bit moving because there's rain falling down. And I've tried to mimic this effect, but without luck, so I'm just gonna stick with a static distortion texture, and that will do just fine, so trust me. Yeah, so just add a simple noise texture and plug the factor into the displacement. So now you can see in the preview what it's gonna be looking like. So let's actually render a little bit of this stuff by going into the rendered viewport, and there we go. It's not really distorting like we can see here. It's really big distortion. Whoops. So to change this, we have to change the scale, and unlike you would expect, to create smaller ripples, you have to increase the scale. So let's increase the scale by 10, so make it 50, and there we go. And I think this effect is a little bit too strong right now, so let's add a math node and set it to multiply, and then we can use this second value to multiply the strength of this effect. So let's multiply it with 0.1, so it's only 10% of the original effect. And yeah, I think this starts to look like this real ground. And one thing I have to tell you is we're not actually gonna see this ground in the render, because we're not gonna use this ground because we have a perfect original shot. So we're only gonna use this extra reflection of the car and of some of the debris stuff and the shadows of the car to add those effects on top of the original shot. So it doesn't really matter if it doesn't look exactly like asphalt, because we're going to use the original shot. So maybe I want to set the scale a little bit higher, 100, and that adds just a little more tiny ripples. And you can fine-tune all these detail and distortion stuff, but I'm happy with this. So yeah, that's for everything for the asphalt ground material. Let's go back out of the rendered view and go back to the default viewport. And yeah, so that's the asphalt material. Very simple. So I think it's time for the math class. So let's look at this, the material we want to apply to these shards. And the reason I want to make this complicated is because, well, like I said, we want to use the original ground of the shot, but when the robot crashes into this, we want to suddenly make the ground shatter. So suddenly the shards have to be visible, and when they are just laying down on the ground, just chilling there, they have to be invisible, because then we want to use the original shot. So that's a little bit complicated, and I came up with a little solution for this this problem we have. And of course there are multiple solutions for this problem, but what I did was I added a lot of nodes into the material. So right now this is called asphalt. Let's call it asphalt shards to not confuse ourselves. And actually let's remove all these nodes and just copy the nodes from this material. So I'm just going to select them all and Control C, Control V. There we go. So now we have the same material, which is a good thing, because it has some reflections and some distortion. But I want to make this invisible at some point. So to do this, we can simply add a mix shader and mix in a transparent material, and make sure this is completely white, and plug it in. And I want to plug it in to the top, so when this factor is set to 0, look at that, material is invisible. When the factor is set to 1, there we go, the original asphalt material. So 0 is invisible, which makes sense to me. And if you like to have it 1 is invisible, just swap these two, and there you go. But I want to make this thing, this vector, actually a factor of the visibility. So yeah, that's what I want to do. But what do we connect to this? Well, that's where the math comes in. What I need to tell you before we start is I thought of this, and as we see, these shards move up in the Z direction. So what I did was, at a certain Z position, they should be invisible, and when they move up, they should become visible somehow. So what I did was I added something that's called a geometry node, and there you have the position. So this position is just the object position. So it's gonna take the position of this object and give it to us through this node. So then we can use the Z position by extracting this position into the 3 components X, Y, Z. So what I want to do to use only the Z value, I'm gonna simply separate RGB. And you may ask, why do you add a separate RGB? This is not a color. Well, this is a vector which is pretty similar to a color. It only has a blue dot instead of a yellow, but we can just connect this and it will work, because positions are vectors with 3 values, X, Y, and Z. Colors are similar because they also have 3 values, R, G, and B. So now red means the X position, green means the Y position, and blue means the Z position. So we want to use the blue one, and then we have the Z position. Okay, so we have a Z position now, and we have a vector to control the visibility. So what comes in between? Well, that's what I'm gonna explain to you guys now. And before I'm gonna do that, I'm gonna just Control G and add these 2 guys to a new group so that I can add them later easily. And I want to make this group very user friendly. So when you don't go inside this group, you want to just set a start position where the shards should become visible, and then another position where they are completely visible 100%, and then just have an output for the vector. So yeah, okay, so I'm going to quickly jump over to my GIMP program, and I'm gonna explain this design. So we want to design a node setup like that. So what I like to start with is a graph, and in this graph I want to have the output of my node group I want to get, and the input. So let's draw this little graph. Whoa. Okay, and over here we have the input, which is, what's the input? Well, the Z value, or the Z position. Let me write it out. Alright, so we have a Z position, which is the input. That's what we get. And we want to somehow convert this into a output. Whoops. Which is the visibility factor. Yeah, let's just write it here. factor. And what do we know about the visibility factor? Well, when it's 0, it's invisible. Let's use another color. Invisible. And when it's 1, it's visible. Oops. So it goes from 0 to 1. And what should this graph look like? Well, at some low Z position, like I said, I want to have, let me use another color. I want to have, at low Z positions, I want to have this, these charts invisible. So that's over here. So low, this, if you don't know what this axis is, it's just the Z position. So these over here, these are low Z positions, and over here we have high Z positions. So at low Z positions, I want to make these guys invisible, like that. And at higher Z positions, I want to make them fully 100% visible. So it should look like this. And then in between, I want to gradually make them visible. So not at a certain step like this, but with some nice graduate form. So yeah, this is what my graph should look like. And this gives me 2 more inputs from the user, which is this position where the charts should become visible, and then another Z position where they are visible. So this is actually just a position on this axis. So let's call this this is Z position. Let's call this visible position. Oh no, this is invisible position, because at this position they are still invisible. And this is the visible position. So we have 2 more variables that we have to be asking from the user. So next step is, well, actually, how would you create this graph with a formula? It's pretty complicated. But what I found is this pretty much looks like just a straight line, like this green one, and a straight line like this, which is being clamped between 0 and 1. And what clamp does is it will clamp any value above 1 and makes it 1, and any value below 0 makes it 0. So let's go quickly back to Blender and add a little math node. And then we can see we have a clamp option, which exactly does what we need in this case. How lucky is that? So yeah, we can create this graph pretty simple if we use clamp, and we just have to come up with this straight line. Well, a straight line is pretty simple. It's I don't know which grade of high school, but let's go to part 2, which is design the formula. And if you don't know what a formula is, well, it has an input and an output basically. So we, as the output, we want to have this visibility factor. Let's just call it factor. And then it's equal to something we input. So the most simple formula we can do is factor is equal to Z position. And that would mean, let me tap out of this, that would mean that we are just inputting this z location into the vector directly. So that's not what we want. So this is a very simple solution, or very simple formula, but we don't include any of these two inputs. So let's get rid of this. Now actually let's leave it, and let's look at the graph. When we are using this formula, let's look at what the graph should look like. And you can guess this probably. It's just, whoa, it's just a straight line like this. Actually, let's make it more like this, because it should be 45 degrees. Because at 0, input 0, the output is 0. At an input of 1, the output is 1. So that means, yeah, we already have a line. So what we need to do now is move this line to the right so that it crosses this point, and then move it and then tilt it a little, or rotate it, so that it intersects with this second point. So first things first, let's move it to the right. Well, some of you guys may know how to do this, and it's really simple. Well, let's remove this little thing, because then it looks like we're doing z minus position, but it's just one thing, z position. How to move a graph horizontally is just adding or subtracting a value from this z position. So actually it's really simple. Okay, let's do this in red. So we have this invisible position where it should intersect, and it's so easy. We just have to subtract the invisible position, and that's all. Now the graph looks like this. All right. And okay, part 2, how to rotate the graph, rotate the line. Well, rotating this line is actually changing the slope of the line, and to change the slope of a graph, we have to multiply it, the complete thing, with some factor. So multiplying or dividing, because dividing is similar. So actually right now, if this visible position would be exactly 1 unit away from the invisible position, it would match. So when this distance is 1, then we're good to go. So I think this distance is important to look at. So let's look at this distance. The distance between those 2 points. And what happens whenever we make this distance smaller, let's say 0.5 units, then the slope should increase, and it should increase exactly by 2. So let's write that down. When the distance gets divided by 2, then the slope should be times 2. So this is a very simple relation actually, because we just have to divide by the distance and then we get the slope. If you divide 1 by 0.5, you get 2. Alright, that's really basic stuff. I'm feeling I'm getting too basic here, but so we have the relation between the distance of these 2 points and the slope. So what we have to do now is just somehow get this distance and divide this whole thing by the distance. So let's take this whole number and divide it by the distance. So what is the distance? It's just the visible position minus the invisible position. So let's write that down. Alright, so now the slope matches exactly this blue line so that it moves exactly through these points. So here we have our formula, and we're almost done with the little math stuff. So now we have to convert this formula to nodes, because we cannot enter a formula into Blender. We have to make it with nodes. So that's very important. So that's actually pretty simple. Let's start with the inputs on the left, which is the Z position, invisible position, and visible position, and the outputs is the vector. Alright, so yeah, how can we get this vector, this number, with these 3? Well, we know how to do it with a formula. So let's do this step by step. Let's first create this number, Z position minus invisible position, and we can do this by using a subtract node. So yeah, let's add a subtract node here, and this little node, and plug these 2 numbers in. Z position minus invisible position. That gives us this number. So we can do the exact same or similar thing with this other number with another subtract node. Let's get the visible position and subtract the invisible position. And we get this number. So now we have these 2 numbers. It's just a matter of dividing, and there happens to be a divide node, so let's use that. And it takes 2 numbers, and first the, how do you call it in English? I don't know, numerator or something. Let's just call it the first number and the second number, and that would be exactly what we want. And this output gives us this whole thing, which is equal to the vector. So now we can plug in this into the vector. How cool. So actually it's a pretty simple node setup, but we have to go through this process to come up with it, because well, maybe you can, but I cannot come up with this from scratch. And now we have a very user-friendly node group, because the user can just say, okay, I wanna get the invisible position, or start making the shards visible at this Z location and make them completely visible at this second Z location, and that's all I have to worry about. So that's what we did, and let's create this node for real now in Blender. Alright, so let's select the group and tab into edit mode so that we can edit the group. And we already have this add node. There's my group output. Let's expand this window a little bit. Alright, so I'm gonna set this to subtract, and if you remember, blue is the Z value. I want to subtract blue. No, I want to subtract the invisible position from the Z location. So now we can rename this over here. Let's call it invisible position. And let's duplicate this node to have a second subtract node, and then plug in the visible position, and again subtract this invisible position. Alright, and duplicate once more and set it to divide, like that. And now we have this let me go back. Now we have this green line, so all we have to do now is clamp, and then we get the blue graph exactly how we designed it, if nothing went wrong, if I didn't mess up anything. So yeah, I think it looks good. So plug in this value into the output and call it factor. Alrighty, so now when we tab out, we have this really user-friendly node group where you can set the invisible position, visible position, and you get this factor which you can plug in into your mix shader. Okay, so to test this out, let's go to the default layout and select all my asphalt shards, all my groups actually, and move it to an empty layer, which is layer 4, happens to be empty, so let's move it to layer 4. There we go, and then only make layer 4 visible, and go back to the impact point. Actually go back to the node view so we can edit these settings here, and right now they're both at 0.5. Let's make the invisible position 0. So what happens now is when the position of the nodes is 0, or the Z location, the Z position, when the Z position is 0, it is invisible, and when it's lower, it's still invisible. And then when it's somewhere between those two values, it becomes visible, and when it's the Z location is 0.5, it's 100% visible. So let's test this out. Okay, looking really weird here, but this is actually normal, because what we see here is the invisible, what we see here is the inside material, this one. So, and the asphalt is invisible right now. So let's look at this node setup of the invisible material, or the inside material, and it's just a diffuse shader, but that's okay. Maybe set the roughness to 0.5 to make it a little bit different, as you can see, because the the shards are not very smooth, so they're a bit rough, and maybe a little bit darker too. Okay, that's okay. So now let's go back to this group we created, and let's select the 3 nodes we added, these 3 guys, to make the material invisible. Select them all, copy, and paste. And let's plug in this material over here. It's really small now. Let's zoom in. Alright, and immediately it starts to become invisible, or at least almost invisible. And let's go a few frames, and there we go. When the robot hits the ground, the shards start to become visible. Isn't that cool? Wow. So yeah, the distance between the two values here is a little bit high, I think. So maybe we should lower this visible position so they become visible a little bit faster. So yeah, but I think it works, and we've proven that the node design with the graph and all the math stuff is really useful in some cases. So let's make this make these shards become visible a little bit faster. Oh, that's pretty cool. Alright, so maybe set it to 0.2. And now only the asphalt inside becomes visible sooner, so we also have to set this one to 0.2. And I think it's pretty cool. Let's look at it from the camera perspective. And I think it's pretty cool. We can see these edges are somehow a little bit visible, so maybe we have to lower this a little bit. So let's start with minus 0.05. Oops. Oh, actually, let's set it to 0.05. My bad. There we go. Maybe 0.1. Still, some of them are visible. 0.15. I don't know, it may be a bug or something, but I don't think this will bother us when we are rendering. Let's leave it at 0.1. Oh, of course, I also have to change this asphalt inside to 0.1. Oh, and that completely solves our problem. So try 0.05. Yeah, it looks pretty clean here. So the shards become visible whenever we want to, whenever we want them to, and yeah, pretty good stuff. Now we have this little crash scene, which we can composite on top of the original ground really easily. And that is how I solved the problem of the shards. So I hope you guys learned something about how to design a node setup, which may seem complicated in the beginning, but when you follow some simple steps, you can get to your result and have a consistent design process. So that's pretty much what I wanted to teach you guys in this part. Maybe I want to add some more materials for some other stuff so that we don't have to do that in future parts. So let's select these debris objects and give them the asphalt shards material as well, and it only applies it to one of them. So let's keep them all selected and Control L and link the materials just like that. And then this one, that is the droplet, if you remember, for the splashes. I actually want to add a pretty realistic water shader to this, so let's call it water. And I'm not gonna change the node setup or anything, just set this to glass and set it to pure white so that we don't have any absorption, and then set the index of refraction to water, if you remember, 1.333. That's what we want. So yeah, now these splashes look a little bit more realistic, and that is all for now. So yeah, didn't forget anything. Thank you guys for watching, and I will see you in part 6, where we will be doing the render layers and render passes. It's almost done, guys. Well, part 6 will be render layers. Alright, see you then.